This is Dave, aka the Guru, and another tutorial using Gamesalad. This is part 5 of our look at the physics engine. So in this tutorial, I've decided to give you a look at my process when I'm building games, and while we're doing that, we'll explore some different aspects of density and making objects move in a particular dimension that we want them to. So I'm going to kind of fly by the seat of my pants here as we do this, as I really don't have anything planned. So we're going to look at how we begin to do things in Gamesalad and how I do my process of working out different issues and planning my game mechanics. So what I've decided to do is I'm going to go ahead and let's just say that I wanted to make an object to hit it and then push it off of a platform of some kind. So I'm going to just grab an actor here, and in the scene I've already come up and I got a gravity of 100. That'll work good for us for right now. And let me just come into this actor and make sure that it's not movable, and there's no bounciness or anything on it. And so now one of the interesting things in Gamesalad is that in the physics engine of Box 2D, 50 pixels actually equals 1 meter of length. So let's go ahead and let me just grab this actor here. Let me see if I've got any code in it, and if so, I'll get rid of it all. And let me go ahead and I'm just going to shut all this off, and let me change the size of the width. I'm going to change that to 50, so we can basically, I'm just going to get something that I can measure with here. And we're going to go ahead and we'll just put this right here at the edge, so it'll give us like a colored aspect of there. So this first section here is going to be 50, and then what we'll do is we'll copy that and we'll just drag it and use the arrow keys to tighten it up, and there we go. Let me change the color on that, and we'll do it to this. So this is essentially going to give us a measuring stick of every 50 pixels. So let's go ahead and just grab our little platform block right here, and we'll place it right on top of that. And let me make sure this is not moved. Yep, it's not movable. Okay, and I copied it. So let's go ahead and we'll grab our little platform, and we'll movable fixed rotation, and we'll go to 0, and we'll set the density on this. Let's set it to 100. So we've set our density on this little actor to 100. Now let me take my player actor here, and I'm just going to kind of set him up. And now what I'm going to do is I'm going to fire a bullet off of this guy, out of this guy. Let me break that prototype. And I don't want this to move. There's no need for it to move. So let me just go ahead and let me make a bullet actor, and we'll call this bullet. And we'll just go ahead into this, and there's a fixed rotation, and let's just take the bounciness off it for now. And usually when we strike something, the two densities matter. So let's just go ahead and leave that just right now for 1. And then what I'm going to do is I just want to make a little switch so that it'll stop firing when it collides with the platform, because I just want an impact. So let's go ahead and just make a quick rule that says when actor receives event, overlaps, and collides with the platform, we're going to go ahead and we're going to change attribute self stop to 1. And then let's go ahead and make another rule, and we'll say when attribute self stop equals 0, let's go grab the move behavior, and we'll just set it. That way we get a consistent speed on this, so we can see I don't have to worry about it ramping up, and we got the direction the right way. I don't want this additive, I want it stacked. So basically it'll cut out this this move behavior here on our bullet. So now let's go into our actor and let's just make a rule, and I'll just use I'll use the space bar to spawn the bullet. And let's go ahead and grab the spawn behavior. And we'll spawn our bullet actor relative to the actor. We want the direction relative to the scene, and the position can be relative to the actor. And so let's just see what we've got going on here. And we need to add some collides here and do a couple things. So let's go into the tabs, and I believe the one that I grabbed was the adjustable. So let me go into my actors, and I have collide, and just let me put adjustable in here. Let's see what I've got in here. Blah blah blah. Okay. So now this block should collide with those. Let me just check that real quick. And maybe I don't have any collides in here. Yep. Let me break this and grab collide behavior and collide with anything in the tag that's collide. And also let me make sure I go in here and grab my bullet actor and throw that under my collide tag. That's what's nice about tags. It really makes it really easy to add new things to your colliding when you're working. And this is how I like to work. I like to set up little prototype instances. You can do it right in your game. You don't even have to leave the Gamesalad project that you're working on. You can just come up and just add a dummy scene. For now, I usually have a dummy scene that's just blank that I keep on there, and then I'll drag actors and things in and do this work and do my testing, start building out my code, and then I'm not trying to transfer things across projects. I have it all kind of contained, what I've created in the code I've already built. I have it already in my project, and then I just can go ahead and bring those actors in once I've established how the code works. And this really is the great way to really test everything out before you start really getting it into your game mechanics. Saves you a lot of time instead of going through like a whole level or blah 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 and jumping through all the hoops to get to that one spot where you're doing something. This really helps you work it all out, keep the code intact, and then go ahead and implement it into your scene much faster. So now let's go ahead and I know what one last thing I want to do. I'm just going to change the size of the bullet actor, and we'll go ahead and just make it 10 by 10 right in here. Okay, so let me just save this, and we'll go ahead and let's see what we've got going now. So spawning the bullet, and bang, we've hit it, and we can see we're not really moving it very far at all with the density that we have. We have this density set to 100, and so the striking object really needs to have a much higher density. So let's go ahead and we'll just double it. Let's double it. We'll just do this one as 200, and then we'll see how that interacts. So now we see that we've hit it, and it's moving, but you see how it's like still going. The velocity on this is very low. So if we took what I would normally do is I would come in and I'm gonna grab a display text real quick. So when I'm working on something like this, I'll go in and then I'll grab a display text, and I'll go ahead and I just want to measure the X velocity on this to see what's going on. Linear velocity, even though I know what's going on, I'm going to demonstrate it to you. We'll just make this white, and we'll push it up 100 pixels, and this will give us an indication of what's going on here. So we'll go ahead and fire our bullet, and so as we can see, we've put it on a velocity, but it's staying on that velocity. It's a very small velocity. It's 4.8, and that's because realistically it's almost like being in outer space. We're not really using any friction here or any of that kind of stuff. So what I like to look at is like this impact velocity, and then you can see it finally comes to a stop. That's really not natural. So we saw that it was like around 4. So we could come over and just grab some drag to give it a little more natural, and we can say, hey, let's throw a drag of 3 on there. So essentially what's going to happen is when I strike the object, once the drag kicks in, you can see it's not going to move very far. And you can adjust the drag up if you want to get it stopped sooner. But we're not really getting much movement in our fixed 50 pixels of range. So let's go ahead and let's increase the velocity in our bullet. So let's go ahead into our little bullet here, and let's double it and see what happens. Let's go to 600, and let's fire it, and bang. And now you can see we're almost about halfway there. So let's go ahead and go to 1,000 and see what happens. Let's go to 1,000 and let's hit it. And so now we can see that we're pushing it pretty well, and we're right about at where we want to be. So we've moved it approximately 50 pixels, which is 1 meter. So let's just see for what happens if we just double this. Let's see how the physics engine responds and see if it goes 100 meters. Let's see. Yeah, it goes a little farther than that. It goes a little farther than 100 meters. So we could drop it back to, let's go 1,800. And see what happens. We're still going just a little bit far. So let's go 1,500. And see what that gets us. That puts us right about at where we want to go. So now, as you can see, by doing this way, what essentially I've done is, let's say I wanted to move something, and I'm building a game where this velocity of the bullet coming out can be a range. So like a cannon physics type game, if I've got a power meter and boom, I hit it, and I have a max power range and I have a minimum power range. Now, having done these tests, I know that the first velocity it takes to move it 50 meters was 600. So I needed at least 600 to move this object with this set at these densities and stuff would be 600. And then I needed a velocity of I believe I put it at 1,800, I think. 1,500. So I needed a velocity of like 1,500, and then pretty sure the first one was velocity was 1,500. So anyways, I know my range here that I need to get it to move 50 pixels, or what I needed to move 100 pixels overall. And so basically what this does is gives me starting points in my game. So if I had if I had these as stacks of boxes or crates, which you commonly see used as in games. So if I went and tested what I needed to do to, as far as the impact, to move this, off the stack, let's say, or whatever, now I can begin to calculate the kind of range of velocity that I need in my meter. And so by stacking these up and testing them, I would know that if I had this stacked on top of a crate, that I would need to, so let's go ahead and let's do it this way. So let's say, let me get rid of this. And so now let's take these and we'll stretch them. Let me go ahead and change these, and let's go ahead to a straight 100 by 100 on this. And let me just get rid of that one, and we'll just copy this. So now if I had these set up like this, typical crate stacking, and then I had this one in the middle here, it's pretty close. And I know that now to get this, over the edge, I'm going to need to strike this several times. So if I struck it, it's going to go. And I've moved it approximately 100 pixels because I was over these two edges, and now I'm almost over this edge. So I would know that in order to push this off all the way, if I wanted it to be hit in one strike that I would need to have my velocity over 1500 to be able to do that. If I wanted it to take more than one strike to hit this box off, then I know I want to keep my velocity of my meter under 1500 to accomplish those things. And so this is how we begin to work out in Gamesalad, prototyping and figuring out how to adjust things. So if we came down here and we drop this down to 1,000, and we can monitor that variable and change it. And so I strike it, and it'll stop, and I strike it again, it'll stop, and I strike it again. I should push it over the edge this time, and there it goes. So now the other thing is I've got fixed rotation on this. So if we went in now and said, well, when you reach your tipping point, which is this middle axis here, we want you to go over the edge. So we would just come in and uncheck fixed rotation, and we would go ahead and shoot it again. And once it reaches that point, it's going to tip and it's going to fall off. And so now we can begin to calculate. Now another way we could also do that without changing the velocity. So let's go ahead into this platform actor and let's reduce its density by 50. So if we reduce the density by 50, we're going to get far more push on this actor than so you can play with the density as well in stacking your different objects. So if you wanted, different objects in your stack here to be harder or easier to hit off or move, you would just change the velocity. You would change, the density of this actor, and you can play around with, the density and the amount of drag you put on it, or you can vary the velocity of the object that you're using, like a cannonball, whatever, to strike these things. So it just really comes down to, getting some base measurements, getting some base parameters, knowing beforehand, what you want exactly to happen here in the mechanics, and then working in your little prototype with simple actors and all that stuff, and getting your raw numbers, getting your raw code built, doing physics stuff. And then once you've got it all worked out, you can go ahead and then take these actors that you've made out of the palette, and you can go ahead and bring them into your game and start setting it up. And prototyping like this really, really helps you kind of do all those little adjustments that you need to do, as you can go back and forth really quickly between the actors, and you have this kind of static scene setup where you don't have to go through all the elements of your game to figure out how to develop stuff. And this works for any kind of coding you're doing, not just parameters necessarily with the physics engine in this. But this is the basic way that we begin to explore. Being curious and exploring and getting data is one of the best ways to really understand how Gamesalad works, is to actually get in there and play around with it, mess around with it, make different adjustments, try a little bit of this, try a little bit of that. Once you know how the basic behaviors operate and what their limitations are, what the pros and cons of the different behaviors are, what the pros of how drag works, how friction works, and figuring out what settings and the range of those settings, how they really affect what you're trying to do. And really experimenting is the best way to get in there and build that equilibrium of what you're trying to accomplish before you get into your game and you've built all these things and then you realize, oh, that it doesn't work and I've got to redo everything. I always like to build up these little setups and really quickly, pull together some simple things just to get some raw numbers, some raw data, so that it puts me in a framework where I begin to know, what's the threshold of what I'm doing and how I can begin to make my adjustments to test and set up what I want to do. So anyways, this is Dave, the Guru. I'll see you in the next video.